Hey everyone, and welcome. Today we're opening up the cookbook for all life on Earth and looking at the ultimate recipe, evolution. It's the incredible story of how just a few simple ingredients, over billions of years, could cook up every single living thing we see around us. Let's dive in.
So, to kick things off, here's a little puzzle for you. What on Earth could a giant, ocean-dwelling whale possibly have in common with a wolf that roams the land? I mean, they look nothing alike, but the answer is hiding deep inside their skeletons, and it tells us a pretty amazing story about where they came from, and where we all came from for that matter.
Believe it or not, the answer is hip bones. Yeah, whales have them. They're these tiny, useless bones just floating around inside their bodies, not connected to anything. They're called vestigial structures, and they're basically little ghosts, tiny reminders that their ancient ancestors actually walked on land. These bones are a fossil record written right into their bodies, and they're the perfect clue to get us started.
Okay, so that one little clue in the whale's body points to a much, much bigger idea. So let's get right to it and define our terms. What is evolution anyway?
So here's the official scientific definition. Evolution is the change in heritable characteristics over generations. Now, heritable is just a fancy word for traits that get passed down through your genes. You know, things like your eye color or your height, not a skill you learned like riding a bike. So evolution is really just tracking how the genetic recipe of an entire species changes over time.
And when you zoom that idea way, way out, we're talking billions of years, you get to something pretty mind-blowing. Every single living thing on this planet is related. Every tree, every mushroom, every fish, every person. We can trace our family tree all the way back to a single organism, what scientists call the last universal common ancestor, or LUCA. We are all just different leaves on one single, gigantic tree of life.
All right, so if we're sticking with our recipe idea, every good recipe needs ingredients, right? For evolution, the main ingredient is variation, all those little differences between individuals. So where do these ingredients for change actually come from?
Well, it really boils down to two main things. First up, you've got mutation. Think of these as random typos that pop up in the DNA code. This is the ultimate source of all brand new traits. And second, you've got sex and recombination. Now, if mutation creates new cards for the deck, sex is what shuffles that deck, creating a totally unique hand for every single offspring.
So we have our ingredients, all that juicy variation. But you can't just throw ingredients in a bowl and hope for the best. You need a cooking method. For evolution, that method is the powerful engine that drives all this change.
And this is where Charles Darwin had his absolutely brilliant insight: natural selection. It's actually a really simple four-step logic problem when you break it down. 1, way more babies are born than can possibly survive. 2, all those babies are a little bit different from each other. 3, some of those differences give them a little edge at surviving and having kids of their own. And 4, the helpful traits get passed on. You just let that process run for millions of years, and voila, the whole population adapts.
But selection isn't the only game in town. There's also this other thing called genetic drift. Natural selection, over on the left, is all about adapting. It favors traits that actually help, like camouflage for a moth. But genetic drift on the right, that's just pure random chance. It's not that a rare flower color was bad, it was just unlucky and got wiped out by a rock slide or something. So one is survival of the fittest, and the other is really just survival of the luckiest.
Okay, so you take the ingredients of variation, you apply the cooking methods of selection and pure luck, and what do you get when it all comes out of the oven? You get the finished dishes, all the incredible, awe-inspiring diversity of species we see today. And we can see the evidence of this shared recipe in something called homologous structures. I mean, just look at the bones in a human arm, a bat's wing, and a mouse's front leg. It's the exact same set of bones, the same basic blueprint, just modified for totally different jobs: grabbing, flying, walking. It's a dead giveaway that they all came from a common ancestor.
Now, over these huge stretches of time, all those little modifications start to add up, and they can lead to speciation. This is the birth of a totally new species. It's that moment a single branch on the tree of life splits into two, creating new paths that will never cross again.
And the classic textbook example of this is, of course, Darwin's finches. Here's what happened. A single type of finch landed in the Galapagos Islands. From there, different groups spread to different islands, where the food was totally different. On one island, maybe you needed a thick, strong beak to crack nuts. On another, a thin, pointy beak was better for snatching insects. Over time, they became so different that they weren't even the same species anymore. One ancestor branched out into over a dozen new species.
Now, it's really easy to think of evolution as something that happened in the past.
dinosaurs, fossils, ancient history. But it's not. It is happening all around us, right now, and understanding it is more important than ever. I mean, get this. We can literally watch evolution happen in a test tube. There's this one famous experiment where scientists have been growing E. coli bacteria since 1988. And after about 31,000 generations, which is just a blink of an eye in evolutionary time, one of the colonies suddenly evolved a brand new superpower, the ability to eat citrate. It was a real-time, observable evolutionary leap. It's amazing.
And this has huge consequences for our health. Antibiotic resistance is just a terrifying, real-world example of natural selection. The bacteria that survive our drugs live to reproduce, creating superbugs. The flu virus evolves so fast we need a new vaccine every single year. Even cancer is an evolutionary process as tumors adapt and evolve to fight off our treatments. This is an arms race.
30%. Take a good look at this number. Just let it sink in for a second. What do you think this represents in the story of evolution today?
It is a truly shocking forecast. Scientists estimate that up to 30% of all species on Earth could be extinct by the middle of this century. And this isn't because of an asteroid or an ice age. Our actions, changing the climate, destroying habitats, are creating one of the most intense and rapid selective pressures this planet has ever seen. We are driving a mass extinction event.
And all of this really brings us back to a famous quote from the great biologist Theodosius Dobzhansky, who said, "Nothing in biology makes sense except in the light of evolution." And he was so right. It isn't just an idea in biology, it is the central unifying theory that ties everything together from the tiniest gene to the entire global ecosystem.
Look, evolution is the story of our past. It's written in our DNA, in our bones. But today, right now, we've become the main force driving its future. For the first time in 4 billion years, a single species, us, has the power to consciously steer the evolutionary fate of almost everything else on this planet. So the real question isn't just what evolution is, but what we're going to choose for it to become.